like I said, you commonly discuss mixed numbers, recipes, quantities, but mixed numbers do not go well in algebra, okay? They do not work well in multiplication. They do not work well in division, right? I don't know if you remember this, but if I said to you, here's an example, 2.5 multiplied by 3, you would say, well, the answer is not 6.5, by the way. You would say, first I got to make this a mixed number. 5 halves times 3 over 1, which is 15 over 2, which incidentally is 7 1/2, right? You cannot multiply mixed numbers efficiently. So, what we're learning today is how to work with that. And example 1 teaches us to take a mixed number, they're not writing it, but I'm using the words you all have learned, and converting it to a fraction in simplest form, okay? Be aware of this lingo, because later when you look at the assignment and you say, I don't know what a fraction in simplest form is, this is what I'm saying. If I have a mixed number, like the example they give you, 2 3/4, and they want me to convert it to a fraction in simplest form, what they are really saying, my friends, is convert it back to the improper form that you were always in trouble for when you didn't do it, okay? So instead of me yelling at you for leaving it improper, now I'm going to yell at you for leaving it a mixed number. Isn't that great? Okay, so your answer would be 11/4. Would you agree with me? Do you guys remember the little tricks that we did to do this? I don't know if you do, but I'm going to really quick kind of draw it big. 2 3/4. Percy reminded me of this just the other day. You start here, you multiply by the 2, and you add the 3. You multiply by the 2, and you add the 3. Okay, so 4 times 2 is 8, plus 3, that gives you the new numerator of 11, and the denominator simply follows. Okay? So that's the little trick. Percy called it the reverse check mark. All right. The reason for this is oftentimes we're going to have to add stuff together that's not a whole number, or that's mixed, or any combination thereof, and you need to be prepared that if you are combining improper fractions with whole numbers, you have to somehow make them the same type, which is why fractions in simplest form are always going to be your friend, okay? So fractions in simplest form might look like this, okay? Or it might look like this. Why did I do that? Because it's a whole number, okay? If I need to use this in an application that requires fractions, I got to throw a 1 under it, okay? Or maybe 5/4 is another example of a fraction in simplest form, okay? C over 1. Now we're getting variables involved, okay? X over 2. Okay, so these are just some examples of what fractions in simplest form might look like. Okay? Examples 2 and 3, we're adding, subtracting, and the fractions look different than they did yesterday. C, this is A, plus 5 over C. Notice I left a big space here. What do you think I'm going to put under that C to make it a fraction in simplest form? A 1. Bravo. Okay? I'm going to put a 1 under it. The rules you've learned in 6-4 and 6-5 still apply. Can we add together fractions with unlike denominators? What's the common denominator between 1 and C? C, no, you have to convert them both to C. You can't make this a 1, okay? But if you make both of them C, this one already is, you end up with C squared over C in the first position, and the second item is 5, doesn't change. Okay, you guys tracking with me how I got from A to B so far? Okay, and the rule, again, that I keep referring back to it on page 264. When you have the same denominator, the numerators are affected by the operator and go over that denominator. So the answer to this is C squared plus 5 over C. You'll look at this and you'll say, well, can't one of these C's reduced? No, because you can't pull a C out of this and this to reduce it. So this is going to stand. Okay? So example B, we're going to do that one. What if you're given 5 minus x minus 3 over x plus 2? What am I going to do with that 5? What am I going to put under it? Put a 1 under it. Common denominator, x plus 2. Multiply both pieces by x plus 2. Now the reason I'm throwing parentheses around it is the same reason I did it with that negative thing, what we did just a couple minutes ago. Because you have to remember, the 5 gets multiplied by the x and the positive 2. Okay? So the new first item is going to be 5x plus 10 over x plus 2. And that is going to subtract x minus 3 over x plus 2. Okay, I'm running out of room here, so I'm going to keep going. In order to remind myself that this all gets the negative, I throw parentheses around it. I'm going to continue down here, okay? 5x plus 10 minus x plus 3. Why? Because the negative here and here change the value of that to a negative, change the value of that to a positive. And the rule that I keep referring back to says when you have the same denominator, both the things get combined using whatever the operator is. This is subtraction. And then looks like this. Final step is to collect like terms. How many x's do we end up with?
4.
Bravo. And what's my constant?
13.
Nothing I can do with that, is there? Okay. Example 3. Same exact thing as example 2, only instead of addressing 2 fractions, hardy har har, you're stuck with addressing 3 of them. Doesn't matter, exact same steps. X Ooh, be careful, all those different signs. That's going to trick somebody up. Okay, throwing my 1 under my x. What is the greatest common factor of x minus 1, and 1?
X minus 1.
Great. Okay, so this becomes x squared minus x over x minus 1. That's what this became. Nothing changes here. Plus 5x plus 2 over x minus 1 minus 7 over x minus 1. Since they all have the same denominator, the rule says the items in the numerator position get combined according to their operators. Okay, so this gets added to this, which is going to look like this. and this entire thing subtracts that. Since there's only one thing, it's only the 7 that gets negative. There's nothing else in there. Your end result is going to be x squared plus 4x minus 5 over x minus 1. Factor, we're not done. X plus 5, x minus 1. See, it's never going to go away. Over x minus 1. So I factored this, found factors of negative 5 that create a sum of positive 4. That's 5 and negative 1. Your end result after you've canceled your x minus 1s is x plus 5. Okay, I didn't even bother to write the 1. It's not relevant at this point. Okay, so today you're doing the odds.